and welcome to the live broadcast of Rocket Lab's 12th Electron mission, Don't Stop Me Now. I'm Max Muncy, and I'm coming to you live from Rocket Lab Mission Control. Thanks for joining us as we get ready to go to space once again. Earlier in the week, we stood down from a launch attempt for this mission due to high ground winds at Launch Complex 1. When it comes to launch, there are thousands of things within our control, but the weather simply is not one of them. We're back on the pad today, but we're still keeping an eye on weather conditions and are currently green for launch at T0. Earlier this week, it was high ground winds that caused us to stand down, and today we're tracking heavy cloud this time. At this stage, it's likely we could go into a planned hold at T-minus 12 minutes to wait for a gap in the weather for launch. Today's mission is a rideshare launch to low Earth orbit for NASA, the National Reconnaissance Office, and the University of New South Wales, Canberra Space. One of the satellites on board today is the NASA Andesite satellite. This payload has been created by students and professors at Boston University to study the Earth's magnetic field as part of NASA's CubeSat launch initiative. There are also 3 payloads on board which are designed, built, and operated by the NRO. This mission was procured under the agency's rapid acquisition of a small rocket or RAISR contract vehicle, which allows the NRO to explore new launch opportunities that provide a streamlined commercial approach for getting small satellites into space. This mission follows Rocket Lab's first dedicated mission for the NRO, which was Birds of a Feather, and that was launched in January this year. The final small sat on board Electron is the M2 Pathfinder satellite, a collaboration between the University of New South Wales Canberra Space and the Australian government to test communications architecture and other technologies. We'd like to thank our mission partners for choosing Electron as their ride to space today. It's great to be able to meet the needs of a diverse payload class, from national security to research projects, all on the same mission. Now, as usual, we'll be ending the live broadcast shortly after kickstage separation, so we won't be bringing you live video of payload deployment. Keep an eye on our social media pages for updates regarding deployment after the webcast has concluded. Today's launch is taking place from Rocket Lab Launch Complex 1 on New Zealand's Mahia Peninsula, the world's only private orbital launch facility. From our inception, the mission has been to open access to space for small satellites, and key to that access is launch frequency. We designed and built a launch site that can support up to 120 missions per year to offer our customers unprecedented access to space. Today, Electron is standing tall on LC-1 Pad A, but just out of the frame, work is continuing on Pad B, an additional launch pad within the same complex. By operating 2 pads at the same site, we eliminate the time required between launches for a full pad recycle, and instead we can launch back-to-back within hours, not days, weeks, or months. We've made something of a habit of building launch sites here at Rocket Lab, and the pads at Launch Complex 1 only comprise 2 of the 3 pads that we operate. Right now, we're preparing for our first mission from another pad, Rocket Lab Launch Complex 2. This pad is located at the Mid-Atlantic Regional Spaceport within the NASA Wallops Flight Facility in Virginia, USA. We are just weeks away from our first launch from this site, a dedicated mission in partnership with the Department of Defense's Space Test Program and the Space and Missile Systems Center's Small Launch and Targets Division. Our team recently conducted the vehicle rollout and integrated systems tests to verify launch systems on Electron and the ground systems ahead of this exciting first mission. Let's check out some of the action going down at Launch Complex 2. Stay tuned for updates about our first mission from LC2 in the coming weeks, but for now let's head back to LC1 as we hit T-minus 7 minutes and 30 seconds until launch for today's Don't Stop Me Now mission.
Confirm AFTS is green and enabled for flight.
FTS is green and enabled for flight.
Top clamp is open.
And proceed with strong back retract for flight.
Retracting strong back.
You're looking at our 12th Electron launch vehicle on the pad here at Launch Complex 1. The Electron rocket is a 3-stage liquid-fueled launch vehicle designed specifically for small satellite missions. To date, Electron has flown 48 commercial and government small satellites to space. Successful deployment of today's payload will bring that total count to 53. The satellites on board this rideshare mission are safely encapsulated inside the rocket's nose cone structure, which you can see on the top of the vehicle, and that's otherwise called the fairing. As we make our way down Electron, you can see white stripes have formed around the vehicle's black structure. This effect is created by the cold liquid oxygen in Electron's tanks, which causes moisture to condense as ice on the outside of the rocket. The first stage, the area where you see the largest white band, is essentially one large fuel tank for the 9 3D printed Rutherford engines at the bottom of the vehicle that will propel Electron through Earth's atmosphere on its way to space. Now, when it comes to launch frequency, we've implemented numerous techniques like 3D printing and automated manufacturing to help us build and launch vehicles faster and more often. But what if we could avoid the need to build a whole new stage every flight? This is exactly what our team is working on right now. We are well into our development program to make Electron a reusable launch vehicle, a process that will involve retrieving Electron from the sky with a helicopter after it has descended back through the Earth's atmosphere under a parachute. While we're not conducting any recovery testing on today's mission, you can keep an eye out for recovery developments on our 17th Electron mission coming up later this year. In the past 3 years, Electron has become well acquainted with low Earth orbit, but in the coming months, we'll be venturing a little further, some 384,000 kilometers further. Early next year, Rocket Lab will launch a CubeSat into lunar orbit for NASA. This historic pathfinding mission supports NASA's Artemis program, which will land the first woman and next man on the moon by 2024. Using our Electron rocket and Photon lunar spacecraft, Rocket Lab will launch NASA's Capstone CubeSat into a unique lunar orbit. Capstone stands for Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment. Capstone's primary objective is to test and verify the calculated orbital stability of the near rectilinear halo orbit around the moon, which is the same orbit planned for the Lunar Gateway. The Gateway is a planned small space station that will orbit around the moon to provide astronauts access to the lunar surface. It will feature living quarters for astronauts, a lab for science and research, and ports for visiting spacecraft. Capstone will also test a navigation system that will measure its position relative to NASA's Lunar Reconnaissance Orbiter, or LRO, without relying on ground stations. Capstone is one of the first steps to learn how to operate more robust missions in this orbit, and it's laying the groundwork for future exploration of our solar system. We are incredibly excited to be part of this historic mission, and we can't wait to share it with you. So as we continue through today's count, let me hand you over to the team in Mission Control to listen in on the final minutes before liftoff.
On all stations, this is flight on mission code. From now on, there should be no red flags in your LCCs. And be advised, vehicle is currently green, ready for flight. VMS, flight on mission.
Go ahead.
Please confirm flight computer as goes to green.
Confirm.
And VMS, please lock the auto sequence and confirm.
VMS is locked.
All stations flight on mission. I can confirm we're go for auto sequence start at T-minus 2 minutes. Avionics, flight on mission code.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
All AV bats are on internal
On
power.
the auto sequence.
Confirm stage power is disabled on all 3 stages.
External power is disabled.
All stations be advised, vehicles now on internal power. PLS flight on mission.
PLS copies.
PLS please begin lock skid recirc.
Copy. Beginning recirc.
PLS flight on mission.
PLS copies.
Please disable anti-geysering and confirm.
Anti-geysering disabled.
Stage 1, confirm stage 1 tanks pressed.
Stage 1 is pressed.
Stage 2, confirm stage 2 tanks pressed.
Stage 2 is pressed.
Engine purge active. Deluge running.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Vehicles clear the pad.
Stage 1 propulsion is nominal.
Vehicle is supersonic.
Well, after a brief hiatus, Electron is back in the skies heading to orbit. At T plus 35 seconds into flight, we're coming up to one of the first milestones of any mission to space, passing max Q. This is the point at which Electron will experience the highest
HP
amount of
battery discharge
aerodynamic
nominal.
force on its way to orbit. Let's listen into the call from Mission Control.
Coming up on maximum dynamic pressure. Pass through max Q.
Stage 1 propulsion is holding nominal. Stand by
And there
for
you have it,
Mahia in
Electron
roughly
has
30
cleared
seconds.
max Q.
Entering burnout detect mode.
AOS Chatham Station.
Coming up next is main engine cutoff, or MECO, which occurs when the 9 Rutherford engines shut down after exhausting their fuel reserves. Upon shutdown, the empty stage is jettisoned so that stage 2 can ignite and continue on its journey to low Earth orbit.
30 seconds remaining. Altitude is 50 kilometers. Speed is 1.6 kilometers per second. 10 seconds to staging.
MECO confirmed.
Stage 2 ignition confirmed.
Stage ignition successful.
That's the call we're looking for. We've had successful MECO, clean separation of Electron's first stage, and ignition of the vacuum-optimized Rutherford engine on Electron's second stage. We're approaching T plus 3 minutes into this mission with fairing separation coming
Fairing
up next.
separation complete.
And there it is on your screen. The fairing has separated, clearing the way for payload
Stage
deployment,
nominal.
which occurs approximately 1 hour
Stage 2
after
propulsion is
liftoff.
nominal.
For the next few minutes, you'll be hearing the word nominal quite a bit. The latest call was from Kevin Garcia, our Stage 2 operator. It's one of our favorite words at Rocket Lab, and it simply means everything is going as expected throughout the flight. On your left, you'll see a view of the operators in the mission control room. These are the people you've been listening to throughout the broadcast on the mission control net, and they're monitoring all things launch related, from propulsion and telemetry data all the way through to our network traffic. We've heard plenty of updates from George Buchanan, our
battery
GNC
discharge.
operator today. The Rocket Lab GNC team are actively recruiting for senior roles in our Photon satellite program, so if you have a solid background in mathematics or physics, head to our careers section at rocketlabusa.com for more info.
250 seconds remaining.
Stage 2 propulsion remains nominal.
Up next is the battery hot swap. This step is unique to Electron and its battery-powered pumps housed within the Rutherford engines. The pair of batteries that carried us thus far are nearing depletion, so to finish the job, we swap power over to a third fully charged battery. Let's wait for confirmation from Mission Control.
HVB battery discharge nominal, approaching hot swap.
Throttling down.
Hot swap successful.
Battery jettison confirmed.
As you've just heard, we've had successful battery hot swap. Electron's trajectory continues to look nominal as we hit 6 minutes and 50 seconds into this mission.
Stage 2 propulsion holding nominal.
If you're just joining us, we've had successful liftoff of Rocket Lab's Don't Stop Me Now mission aboard our Electron launch vehicle. We are nearing second engine cutoff with kick stage separation scheduled in about a minute and a half. While on this mission, the kick stage is being used in its most basic form to deploy our customer payloads to orbit. However, the kick stage can be adapted to become a satellite in its own right. With the addition of elements like higher performance propulsion, radiation-tolerant components, and solar panels, the kick stage becomes Photon, Rocket Lab's in-house designed, built, and operated satellite. Keep an eye out for our first Photon mission
battery
coming soon.
discharge holding nominal.
The next major milestone you'll hear is SECO, or second engine cutoff. This marks the end of the second stage burn, after which the kick stage will separate in preparation for payload deployment.
40 seconds remaining.
Entered burnout detect mode.
Guidance is in terminal. Seconds remaining.
SECO confirmed.
State separation confirmed.
And we're going to get transfer.
And there you have it. The kick stage is on its way to deliver the payloads to their individual orbits. For those of you who might be wondering what the kick stage is, here's a quick explanation of how this ingenious machine works to deploy payloads to orbit. Once the second stage takes us to an elliptical parking orbit, the kick stage separates and ignites its 3D printed Curie engine, circularizing the orbit. Using a cold gas reaction control system, the kick stage accurately orients itself to deploy each satellite to a specific orbit. Using this system, the kick stage is able to insert its payloads with precise orbits, even on rideshare missions with multiple satellites like this one. After deployment, the Curie engine reignites, propelling the kick stage to a lower orbit where it will be dragged into the Earth's atmosphere at a much faster rate, leaving behind nothing in orbit but our customers' satellites. Payload deployment is expected in the next hour or so, and we'll share confirmation on our Rocket Lab Twitter and Facebook accounts when we can. A final thank you to all of the small satellite operators on board this 12th Electron mission for choosing Rocket Lab as your mission partner. Thanks for watching, stay safe, and we'll see you again here soon. I'm Max Muncy, and until next time, this is Rocket Lab Mission Control signing off.